Hello, future interns, subscribers, viewers, and students. Here is a new playlist in plane and spherical trigonometry. This is the beginning. I hope that for those who don't like trigonometry, then you must like it by my presentation. I just hope so. And for students who plan to become engineering students in the future, then you must like trigonometry because this is the basic mathematical tool needed for you to become successful as engineering students and hopefully become engineers. So here I discuss the preliminaries of trigonometry. So we have units of length. These are just common. So 1 meter is 3.2808 feet. So 1 foot is 12 inches. And it is also 0.3048 meter. 1 inch, 2.54 centimeters, 25.4 mm. 1 kilometer is 1,000 meters. 1 mile is equal to 5,280 feet. Then 1 nautical mile in navigation is 6,080 feet. So this mile here is to be defined later as we reach spherical trigonometry. Units of angles. So the most popular unit of angle is the centesimal units, which is the hexadecimal unit, which is or sexagesimal units, which is the degrees. So we have here the plane. This is the first quadrant, second, third, and fourth from your algebra, coordinates, and graphs. So this is the initial side, the x-axis, positive x-axis. Angles are measured positively in counterclockwise direction. Again, angles are in counterclockwise direction. Measured in counterclockwise direction is positive, while if they are in clockwise direction, angles would be negative. So take note of that. And we have an initial side, and the terminal side is terminal side of the angle, which are called rays or segment, would be the end of the measure of that angle. So this is 0 degree, 0 radian. The radian is the SI unit of angles, by the way. 0 grad or gradians, and 0 of a revolution. Or the other unit of angle will be explained also later, so you have to listen. This is equal to 90 degrees, which is equal to pi over 2 radians, because the whole full angle, which is 360 degrees, or 2 pi radians, 400 grads, approximately 6,400 mils, MILS. That's only an approximate use in military, but nowadays mil is the abbreviation for milliradians, meaning to say 1 over 1,000 of a radian. And 1 radian is equal to 180 degrees over pi, or 360 degrees over 2 pi radians. So 1 milliradians, we divide that further by 1,000, so 0.0573 of a degree. Then if it is 1 over 6,400 times 360 degrees, then that would be 0.9 over 16, or 0.05625. So they're close but not as accurate. So the more accurate value for milliradians is that 180 degrees over pi divided by 1000, so 0.0573. So that's of a degree. So that's the value of 1 milliradian. So this is equal to 100 radians or 100 grads, and it is equal to 1/4 of a revolution also, or as I said, this is in mils, you can convert that. Then for this angle in counterclockwise direction again to be positive, the terminal side ends here. We call this quadrantal angle in our succeeding topic. So this is 180 degrees equals pi radians to 100 radians. Then here we have 270 degrees, 3 halves pi radians and 300 grads. Then one full angle or perigon, we call that perigon, is 360 degrees, 2 pi radians, 400 grads. So take note of that. So therefore, one revolution is equal to 360 degrees, which is also equal to 2 pi radians, and which is also equal to 400 grads. So just familiar with these common units of angles because these are widely used in books. Other angles such as mils used in military operations for accuracy and in navigations also. So next, let's have the shape of the protractor so that we can lay off angles accurately. So this is the picture of the protractor. So it begins with 0 here, 10, 20, 30, and so on and so forth until 180 degrees. Then we also have this marking in clockwise direction. But remember, the positive direction of measuring angle is counterclockwise, and if it is clockwise, it is negative. So lay off the following angles: 50 degrees, 145 degrees, 212 degrees, 336.5 degrees. Then on the next slide, we have another batches of angles. So for 50 degrees, from this center here, you have that 50 there. You have to fit the center with the center here. And because this protractor is transparent, then you just mark when this 0 coincides with here. You just mark a point here for that end of that 50, then you just trace that line joining the 0 end and that 50 mark there. So I just illustrate it here. So assuming this is now the 50, then I'll just copy this and put it here. And this angle is equal to 50 degrees in counterclockwise direction. Next is 145 degrees. This is 90, 100, 130. 145 should be here, beginning with 0 as shown. Then again, the 0 end of the protractor should be coincident with this 0 mark here. Then mark the end of that 145, then connect them with a straight line, and that would be the angle 145 degrees as shown. Then for 212 degrees, it is somewhere here in the third quadrant. It's more than 180, so we add 212 minus 180, 32 degrees. So from here, 10, 20, 32 as shown. Then assuming it fits now here, then we can easily lay off 32 degrees. Then from the positive x-axis in counterclockwise direction, that's 212 degrees. Now, It is also convenient to express it as a negative value because it cannot be prevented that we should also deal with negative angles. It is in clockwise direction. Therefore, the negative value is 212 degrees minus 360 because one full revolution is 360 degrees. So 212 minus 360 degrees is negative 148 degrees as shown. So instead, 90, negative 100, 110, 120, 130, 140, negative 148, which is the same terminal side as this. Then for 336.5 degrees, so that's 270, 280, 290, 310, 20, 30, 335, 336.5. So that's it. After fitting it here, then transfer, lay off. So in counterclockwise direction, that's 336.5 degrees. In clockwise direction, 336.5 degrees minus 360 is negative 23.5 degrees. So this is negative 10, negative 20, negative 23.5 degrees. So we can still estimate it like that. So let's have another batch of laying off angles. Negative 90 degrees, negative 165 degrees, 400 degrees, negative 570 degrees. So this time we have angles that are negative and angles that exceed one full revolution in both directions. So first for negative 90 degrees, so it's in this direction, in clockwise direction. So this angle here, we'll just transfer it here. And this is negative 90 degrees. The equivalent positive angle is 270 degrees. 360 degrees plus negative 90 degrees is positive 270 degrees. So that's negative 90 degrees if expressed in positive value, 270 degrees. So 270 degrees and negative 90 degrees are coterminal angles. We call that coterminal, same terminal side, which is a topic in one of the following videos here. So anticipate that. Next is negative 165, so it would be clockwise. 165, this is already negative 140, 150, 160, 165 should be there. Shown, then assuming it fits with the zero mark of the protractor is here, then you mark at the end of that 165, then join with a straight line. That's it. And that's negative 165 degrees. And if you express that positively, it is 180 plus 15, 195 degrees, or 360 degrees plus negative 165, 195 degrees. Then 400 degrees, 400 minus 360 is 40 degrees, so that is equal to 40 degrees from the positive x-axis. They have the same terminal side, but it has already completed one revolution, then plus 40 degrees in counterclockwise direction as shown here. So this is 40 degrees, but from the positive x-axis, we have 360 degrees plus 40 degrees, so that makes it 400 degrees in counterclockwise direction. So again, the angle that this ray makes with the positive x-axis is 40 degrees, but it has completed one revolution, 360 plus 40, so that makes it 400 degrees. And finally, we have negative 570, and that is in clockwise direction, negative 360, one full revolution, negative 360, then negative 90, negative 450, negative 90 again, negative 540 degrees. Then we add in clockwise direction 30 degrees. So it is 30 degrees from the positive, from the negative x-axis. So that's 30 degrees. Let's transfer that here. But it has completed one revolution in clockwise direction. Then we just add, then we have another half clockwise of a revolution. Then this is 30 degrees. So that's it. This is the measurement. So clockwise, negative 360, then negative 450, negative 540 degrees, then another negative 30, that makes it negative 570 degrees. So that's it for this video. I hope that those who don't like Trigo will live slowly but surely we like it as we move on.